Assalamu alaikum and good evening. I hope everyone is able to listen to me. Welcome everyone. I think it's fine. We can start now. Uh, yes, welcome everyone. The today's session. Yeah, can you hear me? Yes, this is Usman Malik from Quest Academy with the online webinar on the topic hazard and operability study in oil and gas industries. Let me first begin with the introduction of the Quest Academy. Quest Academy aims to provide technical and non-technical courses to the students and the freshers, especially who are working in the oil and gas and the process industry. And it gives a know-how and the troubleshooting techniques to the learners regarding the field related to safety, engineering, commissioning, operations, and also the healthcare. So let's begin with my introduction. My name is Usman Malik and I'm a chemical engineering from UET Lahore. Yeah, I have done BS chemical engineering from UET Lahore, Pakistan. Currently, I'm working as a process engineer and commissioning engineer in various EPIC projects of Qatar Petroleum and Qatar Gas. I'm also working as a training manager at Quest Academy. I have the work experience in the fields of operations, HSE, loss prevention, firefighting, commissioning, process engineering, and T&D. I've been providing technical trainings related mostly to the process engineering, commissioning, operations, which includes the safety studies, HAZID, HAZOP, the firefighting and equipment layouts, the pre-commissioning and commissioning procedures, and also some hands-on experience related to the permit to work, lead work trainings, the safety induction practices, and also the document controls. Yes, the layout for today's lecture is the introduction of HAZOP, why it is done, how it is done, what is the methodology of applying HAZOP in an EPIC project, and the examples. Basically, the HAZOP is done as a part of an EPIC analysis in which we do the engineering studies. Actually, HAZOP is a structured and systematic examination of a planned or existing process or operation in order to identify and evaluate problems that may represent risks to personnel or equipment to prevent efficient operation. HAZOP is mostly done on EPIC projects in the engineering phase to look for any deviations in the engineering design and apply mitigation practices. How the HAZOP is done. HAZOP is a qualitative technique based on guidewords and is carried out by a multidisciplinary team, which is usually of process engineers, safety-related personnel, equipment personnel, and also the safety experts. The method applies to processes existing or planned for which design information is available. This commonly includes a process flow diagram, which is examined in small sections, which is known as the markup of the PNID of PNID of the PFD. And also the individual items of equipment or pipes between them. For each of these, a design intention is specified. Now let me explain to you what is meant by the design intention. The design intention is the parameter of the process flow or temperatures or pressures which we have to maintain during the normal operation, and the value of that is the main intention. Like for example, 50 degrees C is the design pressure of a pipe. So if it goes above or below, so we call that as the deviation, and we have to look for those deviations in this HAZOP study and try to reduce and mitigate the effect of the deviations. This is an example of a medium-sized chemical plant. It usually, the HAZOP of this plant will have almost 6 to 9 members in the HAZOP team and 1,200 items of equipment, which includes small valves, small alarms. Okay, then we have the small compressors, small pumps, and we have around 1 to 40 meetings required for this HAZOP, depending on the size and the criticality of the operation. How HAZOP is done? HAZOP is done by defining some parameters and guidewords. Parameters are the process variables which apply to the design intention. Variations in these parameters could constitute deviations from the design intention. Guidewords are employed to each parameter in order to identify deviations in its behavior. What is design intention? For example, in a chemical plant, a pipe may have the intention to transport 2.3 kg per second of 96% sulfuric acid at 20 degrees C and a pressure of 2 bar from a pump to a heat exchanger. The intention of the heat exchanger may be to heat 2.3 kg per second of 96% sulfuric acid from 20 degrees C to 80 degrees C. So this is a situation in which we know what are the operating conditions and what is the design intention of a process operation. So the HAZOP team then determines what are the possible significant deviations from each intention, what are the feasible causes, and what are the likely consequences. It can then be decided whether existing design safeguards are sufficient or whether additional actions are necessary to reduce the risk to an acceptable level. So following are the parameters which are usually noted down and considered during an HAZOP brainstorming session, which is like the main of all these is the flow, time, frequency, and pressure. Following are the guide words. These words indicate the deviation, like the amount of deviation happened during a normal flow. For example, as I told you earlier, that we have a case in which we have the design temperature as 50 degrees C. So if it goes more than 50 degrees C, what is the impact of the excess of that temperature in our design, and what are the existing safeguards to accommodate the increase in that temperature? So following are the guide words like more, less, as well as part of, reverse, other than. So these guide words indicate the deviation of a normal operation, normal process, and how we can mitigate the deviation from the normal operation. So this is the HAZOP process overview. As discussed earlier, we have a HAZOP review team, which includes experts from various disciplines like mechanical, instrument, we have process experts, we have operation experts, and all these teams will give their ideas, and they will share their experiences from various EPIC projects, and they will give guidelines of how we can document each and every hazard and its impact. The material used for the HAZOP brainstorming is like the PNIDs, the equipment layout, we have the PFDs, we have the heat and material diagrams, and all those materials, stuff is like documented in a file and distributed to all of the HAZOP team. Then we have the documentation. There will be a scribe who will note down all the points discussed during the meeting and give it in a layout of an Excel sheet or a Word file or a table, which will have like 5 columns. The first column would be the deviation. Why is the system moving from one point to the other? What is the deviation? Then what are the causes of that deviation? What are the consequences of that deviation? What are the safeguards to prevent that deviation? And what are the actions to accommodate that deviation to mitigate the deviation effect? And then all of this brainstorming study is compiled into this document, which is called the worksheet, HAZOP worksheet, which is formalized by a report. And that HAZOP report is circulated to all of the stakeholders, and then it's followed up so that the design is free from all sort of deviations and hazardous deficiencies. So in short, the HAZOP includes the following main concerns. We have the intention, the deviation, we have the causes, consequences, which includes the hazards and operating difficulties, the safeguards, recommendations, and actions. Let me also give you another brief information about the HAZID. Before doing the HAZOP, there's another brainstorming session which is called the HAZID, which is called the HAZID identification. That HAZID identification is a bird's eye view of all the disciplines, and it accommodates not only the process engineering, it also includes all the other disciplines and the ways how we can mitigate the hazards which can happen during the normal operation. So prior to HAZOP, we have the HAZID, which will be discussed in another session. It's a more relevant thing for the project managers and for the people who are working in the project team. But the HAZOP is purely related to operations and the plant processing, like the operations and the processes which will occur when it is normally operating, which is more concerned to the process engineers. So let's discuss the HAZOP flow sheet. we have this process section or the operating step. We will select that, like for example, we have a heat exchanger. We will apply HAZOP study on that heat exchanger. So for that, we will select the heat exchanger and we will try to explain the design intention. We will try to give the process variable a task, and also we'll apply the guide word like more, less, what happens if the deviation goes up, goes down, and we will examine the consequences associated with deviation, and we will list out all sorts of deviations, like if the temperature can go high, it can go low, what are the deviations which can happen in a system. We will identify existing safeguards to prevent deviation, like we can add alarms, we can add another inhibit systems, we can also add fire alarms, we can also add automatically operating controls, ESDVs, SDVs. So after that, we'll assess the acceptability of risk based on consequences. We will develop action items which can include the updation of SOPs, creation of maintenance and operating manuals. And then we'll repeat that for all guide words one by one. And then we will repeat that for all the process variables like temperature separately, then pressure, then viscosity, then level, then flow. All these we'll discuss in the HAZOP worksheet. And then we'll repeat all that for the process sections. Like we have different sections. We have the gas pressurization section. We have the distillation column. So we'll discuss it separately in bits and pieces. So for that, we have another session planned next week in which we'll give a brief idea of how to mark up a PNID or a PFD prior to the HAZOP analysis, in which we'll mark based on nodes. Actually, we have nodes in HAZOP in which we have starting and ending points, and whatever happens in that node is considered as one section of HAZOP, section of consideration. So next we have the HAZOP methodology. As discussed earlier, we have 5 columns in that hazard operability worksheet. The first one is the deviation, which is the parameter which is going to change its value, like flow, temperature, pressure, anything, any process parameter which can change its value from the main specified one. So it can be flow, it can be temperature. So we'll first note down the deviation, and then we'll identify what is the potential cause of the deviation, why the temperature goes up, why it can go down, why the level can go high. And then we'll compile the consequences of the cause and the deviation. That what happens if the level goes high? What happens if the pressure goes high? Will there be a rupture? Will there be a leakage? We'll note down all such aspects like very precisely. We'll note down the tag numbers of the vessels. We'll note down the tag numbers of the valves, which can leak, which can pass, any specific information. And then the next column, the fourth column, is the safeguards. What are the safeguards which is like present there in the existing design presented in the HAZOP? So we'll consider the existing devices. For example, the fire and gas alarms come into picture. If the leakage happens, so there will be automatically fire and gas alarm inhibition. And then we have the new actions which are not there, and we will suggest as the recommendations in this HAZOP to remove the cause or mitigate the consequences. So in short, these 5 columns are the most important ones during this HAZOP review, and all of these are considered and filled by the scribe and the chairman. So now let's move on to the example of HAZOP. We will try to apply HAZOP on the system. We have a reactor in which we have the cooling coils and we have the cooling water inlet, we have the feed coming in, we have thermocouple to control the temperature. So the reaction is exothermic. A cooling system is provided to remove the excess energy of reaction. In the event of cooling function is lost, the temperature of reactor would increase. This would lead to an increase in reaction rate, leading to additional energy release. The result could be a runaway reaction with pressures exceeding the bursting pressure of the reactor. The temperature within the reactor is measured and is used to control the cooling water flow rate by a valve. So how we can apply HAZOP on this example? What we'll do, first of all, as discussed earlier, we'll try to compile the guide words. We'll try to compile the parameters, and we'll try to solve them one by one. So we have the guide word. The first guide word is no. So the deviation which can happen is that no cooling. Like for example, what happens if there is no cooling? We'll try to brainstorm and we'll try to gather all the ideas. What happens if there's no cooling? Before that, we'll see what are the causes of no cooling happening inside the reactor. So what is the cause? That probably the cooling water valve is malfunctioning. And what is the consequence? That the temperature increase in the reactor is there, and because of that the reactor can either burst, or it can either overflow or give uh, an improper reading to the operator. So what is the action for that? We can install high temperature alarm, which can give pre-trip alarms to the operator, so that the operator can control and intervene into the system, and again make the cooling system normal. The second guide word is reverse. Like for example, this cooling flow is meant to flow from point A to point B, and what happens that it's reverse cooling flow from B to A. So the cause of that may be because of the backflow, back pressure, the differences, the differential pressure, the differences in the flow, and the consequence may be less cooling and possible runaway reaction. The reactants may be included with some of the products, and there will be some improper reactions which can lead to less production. So what is the action for that? We can install check valves, and as you know that check valves maintain one flow, one direction from point A to point B, and it will stop the flow from point B to point A. The third guide word is more. The deviation in this case is more cooling flow. For example, we have a rated flow of A MMSCFD, and it becomes A plus 2 or plus 3. So we'll consider that case over here. So what will be the causes of more cooling flow? The causes may be control valve failure, operator fails to take action on alarm, would be some like human errors can be the causes for this deviation, and the consequences would be there would be too much cooling and the reactor temperature will go down, and the appropriate standard temperature will not be achieved, and hence we will not get the same quality. So what is the action for that? The action would be that we will instruct operators on procedures. We will update the standard operating procedures to let the operators know of any changes in the cooling flow, so that they can maintain the specified operating parameters. The fourth guide word for this reactor is as well as. As well as means that we have, for example, one feed of benzene, and we need just benzene to add into the reactor, and what happens due to some leakage or some problem, another stream enters into the system. What will happen in that case? We'll try to gather some information regarding that. So the deviation would be that reactor product in coils may enter into the feed, which is the benzene, for example. The causes may be leakages, and the consequences will be off-spec product. So what is off-spec product? That we have a reaction based on the stoichiometry of the reaction, and if there's some another element being added into the system, so we'll get some off-spec product, and you know the off-spec means that the quality will again be compromised. So the action for preventing the leakages or the reverse flow is to check the maintenance procedures and schedules, and to update the operators, to train the operators on how to operate the valves, how to control the control valves. The last guide word for the reactor is other than. If any other substance is being added into the system apart from water, why this can happen? In case of water contamination, maybe there's some high ore element being added into the water, or maybe because of less treatment or poor water treatment practices, the water is dirty. So what will happen? The cooling will become ineffective and will have effect on the reaction and hence the quality. So what is the action for that? That we will shut down and isolate the water source in case of any contamination, and for that we will try to maintain the procedure. Yeah, so the second example we have over here is the HAZOP for the heat exchanger. And how does a heat exchanger work? It has two fluids, probably like both of them are process fluids, one entering maybe from a cross current or the counter current flow, depending on the size and the variation of the compressor of the heat exchanger, sorry. So we have one process fluid entering from the left, and we have the cooling water going across direction. So we'll try to gather the HAZOP on this heat exchanger. So the same thing we'll try to apply over here. We'll have the guide words over here. We'll try to check all of the cases over here possible, and we have the guide word less. So what happens if there is less flow of cooling water? What happens that the temperature of processed fluid increases, and why it happens? Because of the pipe blockage. Maybe there is some restriction in the flow, because of which the flow of the cooling water becomes less. So what would be the action of getting this less flow? We'll have a high temperature alarm. If the temperature goes high, it means that there is less cooling water being entered into the system. So the temperature alarm has to be updated. The next guide word is more cooling flow. If more cooling flow enters into the system, it is obvious that the temperature will go low. So what do we need in short? We need a low temperature alarm. And what are the consequences of more cooling flow? That the temperature of processed fluid will decrease because of more cooling flow enter. The causes would be that maybe the valve is malfunctioning, maybe there is a blockage, or maybe more flow is coming into the picture because of the valve malfunctioning. The next guide word is more of. More pressure on tube side may be the deviation. The causes for this will be the failure of process fluid valve, which will give more pressure on the tube side. If there's more pressure on the tube side, the consequence may be the bursting of tube. And the action to avoid the bursting of tube is to install high pressure alarm. The high pressure alarm will indicate the operator to reduce the pressure by changing the parameters and by noting down the situation before any sort of mishap. The next guide word is contamination. The contamination can happen because of process fluid. The process fluid can be contaminated by the leakage of tube and water, like intermingling or the mixing of the water into the process fluid. So what will happen because of that? The consequence would be that the process fluid will become contaminated, and the action for that, we'll have to have the proper maintenance so that there's no leakage, there's no intermixing of the tubes, and all the tubes are going on separately so that there's no contamination of process fluid. And the last guide word for the heat exchanger can be the corrosion. With the passage of time, the tubes can get corroded and can give less efficiency. So what is the deviation? The corrosion of tube, which can be caused by hardness of cooling water, the salt content, magnesium carbonate or calcium carbonate in the water, can just spoil the tube quality. So the consequences, we can do less cooling and crack of tube. Like because of hardness of cooling water, so the action would be proper maintenance. We have to do the proper maintenance to avoid the layer of corrosion to be deposited on the tubes and increase the efficiency of the heat exchanger. That's all for today. This was an introductory lecture. Next week, we'll be having a detailed one in which we'll discuss probably more in depth of how to mark the nodes on a PNID. I'll also share you some previous experiences about Qatar Petroleum and Qatar Gas, how they do the HAZOP, what are the standards of doing HAZOP, what are the nodes, how effectively we can try to gather more and more information about all sorts of hazards and deviations possible in a system. And we'll try to also learn of doing HAZOP by ourselves, how to write the HAZOP report and how to fill the HAZOP worksheet. So if any one of you have any questions, or would you like to request for any certificate, so you can drop a message at this number or this email. We have a paid plan for the certificates, and we can give you the certificate as shown in this picture, and we'll be happy to serve you again next week. If any questions, you can just give me a message. Thanks a lot.